Sometime in the not too distant future, you're going to have financial goals. You're going to wonder, how much do I need to save for a car? Am I going to have enough money for retirement? If I save $500 per year for 10 years, is that going to be enough for a down payment on a house? All that kind of stuff. Well, what we're talking about here is the time value of money. And it's a very helpful tool to utilize in all of these financial goals that you will find yourself in the future. Guarantee it. Okay. So we're going to dive into this and we're going to utilize the time value tables. This is Appendix C, which you will find if you're using Google Classroom. You'll find it attached here. But I will refer to this back and forth several times as we go through this. So Appendix C. And really one of the challenges here, the biggest challenge is to determine which table you need to utilize for which situation. And sometimes there's like two possibilities. So anyway, here we go. Fuzzy math. All right. Or business math made easy. So first of all, terminology, just some foundational items to think about. Interest. Now we've talked about compound interest, but what in the heck is interest? Well, it kind of depends on as if it's working for you or working against you. If you're investing, somebody's using your money, you're getting interest or that extra amount for somebody using your money. If you're borrowing money to buy a car or a house or a boat or whatever, then you're paying extra for you using their money to buy something because you don't have enough. All right. And I always like the term of interest where it's the fee you pay for using someone else's money. Fee you pay for using someone else's money. So when we get into time value concepts, interest plays a big part both in the growth of money and also what we will call the discounting of money here in a moment. Compounding, again, you got a little bit familiarity with compounding where every period, and I'm going to keep this simple by just assuming that every period is a year, but a period could be a month, a week, a day, whatever. But the easiest thing to utilize is just to look at compounding being 1 year. So every year you're resetting the amount of your balance, which you've already talked about, like I said, and that money is building and growing almost well, it does after a while really grow exponentially because you're earning interest on top of interest. Your interest is compounding and growing at a faster rate each year as opposed to simple interest. If you're still struggling with the concept of compounding, go back to the unit on simple versus compound interest. Okay? Now, there's four key areas of time value of money. The first of all, given, for example, a dollar or an amount of money and an interest rate, what's something going to be worth, how much money you're getting extra per year, and a number of periods or time, how much is something going to be worth in the future, given a rate of return or interest and time. So that's future value of one. Present value of one, just the opposite. Given a future amount and a rate of return in a number of years, how much would I have to invest now to get to that amount? In other words, given a rate of return or interest rate, what is that value worth in today's dollars, something off in the future? And again, when we say of one, we're talking about a single investment or payment at a point in time. Future value, present value. Annuity is the next term, which is going to be totally new to some of you. Annuity just means that every period, and in this case, every annual or every yearly period, we are making an investment, a payment, if you like. We're making the same payment every year. In this case, we would call that an annuity, the same amount every period. All right. Now, when I say annuity, Whoops. First of all, we need to look at the future value of annuity. So in other words, if I put aside $300 per year for 10 years at an interest rate of 8%, how much will that be worth in the future? Future value of an annuity. Conversely, present value of an annuity, given that I am going to be making $500 payments for the next 20 years, or maybe let's say I'm receiving $5,000 per year for 20 years with an 8% rate of return, or what we would call a discount rate, more on that in a moment. What is that worth in today's dollars? So very similar to the present value of one, but again, that's a lump sum or a single payment. Present value of annuity is present value of a series of payments in a future time period. That's the one that I struggle personally with the most, is present value of an annuity and the application of that. Rate of return. If I'm making an investment, I want to know how much I'm going to get back, or is going to be returned back to me in the form of interest. So I'm using the term interest and rate of return almost interchangeably. Rate of return is kind of an investment terminology. You're basically saying, how much am I going to get back for you using my money for whatever you're using it for? Whether it's a 401k, stock investment, a bond, a personal loan, whatever. How much am I going to get back or return to me? A rate of return. And when we say rate, like interest rate, 99% of the time, interest rates are communicated as annual rates, even though we might be making monthly payments or quarterly payments every 3 months or whatever. Return rates or rate of returns and interest rates, where I'm paying for a car or whatever, are generally communicated as annual rates. So if you're doing a monthly type payment, you might need to make a conversion in your mind on how to do that. Periods, like I said before, periods can be annual, quarter, monthly, weekly. We're going to keep things simple here by just calling every period a year. Please understand that could be all kinds of different time periods. And periods is one of the unknowns or the givens when we talk about time value of money. Installments, very similar to annuity. This would be, and when we talk about an installment loan, say a car loan, you're making the same payment every month for a series of years. We'd say we're doing that in installments. If we're doing an investment, an annuity, we're paying the same amount or investing the same amount every period, every year in this case. Those would be installments. The same payment is being made against a loan. The same investment amount is being invested every period. Installments. Discount rate is when we look at present value of either a lump sum or a dollar, or present value of an annuity. The discount rate is we're essentially using a rate of return to discount or reduce the amount of the investment based on the passage of time. So rather than saying we're earning interest or we have a rate of return, when we're talking about present value, we're discounting the value of our investment into something that's in the future. We're discounting it back to today's dollars, the equivalent of today's dollars. So we refer to the term discount rate, or a reduction in that value based on the passage of time, comparing the future to the present. Again, another concept that's kind of hard to grasp. And I would direct you to, if you're confused about any of these, I would direct you to Investopedia.com. And we're going to use this later on as a study guide, but there's a little magnifying glass in Investopedia.com in the upper right-hand corner where you can look up some of these terms if they're still kind of shady in your mind. All right. So first of all, future value of one. All right. The future value, interest factors for $1 or a lump sum single investment, compounded, added upon itself, interest earning interest, at I% for n periods. Wow, that's like a mouthful. Minus FV PV times FV IN, whatever. It's like, oh my goodness. Yeah, formulas like, whoa, what are you talking about? Well, let's break that down. So what we're talking about here is we're given a rate of return interest, which they're calling I, for the number of periods, n, which is generally years, to come up with, if I invest something now, given a rate of return, given a number of periods, how much will that be in the future? How much it will be worth in a future period. All right? So again, don't get intimidated by those wild algebraic formulas, but just understand that we need to know what the interest rate is, or the rate of return, and what our number of periods are. And essentially, we're just asking, how much will I have in the future given a single lump sum investment at a point in time? We're using table C1. Let me break here for a moment. Table C1 on Appendix C attached in Google Classroom. So we're using this table right here. Okay. And I'm going to be bouncing back and forth. This is going to be kind of awkward, but whatever. We'll figure it out, won't we? Okay. Table C1. If I invest $1,000 today, what is it worth in the future if I have a rate of return of 8% and my number of years are 10? Okay, good question. Well, let's go to our table. Maybe blow that up just a little bit. And again, I'm looking at what is the factor for rate of return 8%, number of years 10. Table C1, future value interest factors for 1. Again, we're assuming annual compounding. 8% for 10 years is 2.159 on my table. 2.159, 8% for 10 years. So after 10 years, my investment of $1,000 would be 1,000 times 2.159, or if you just play the game with the decimals, I would have $2,159 in my account after that period of time. So that would look like this. My factor is 2.159 times 1,000, and I end up with 2,159. And let's see here. Let's pause this if I can. Okay. Short commercial break. Right on? Always fun.